previous video, we learned how to find the maximum height of a projectile that's launched basically straight directly upwards. Now we're going to look at a projectile that's not launched directly upwards, but it's launched at some angle theta and some initial velocity v. Well, we don't care that it might be going in this direction at this velocity, say 10 meters per second, but we do care much more that it might be going upwards with a certain component of that velocity upwards. So let's say that that angle is 30 degrees. I should write that a little better. So 30 degrees, and then the upward component of this 10 meters per second we'll call Vy initial, because it's going to change. We can't just call it Vy. So we're worried about that. And similar to our last problem, we used that as our initial velocity in the upwards direction. We're going to have some of this motion. Yeah, it's going to go left to right, but at some point along the way, we're going to reach that maximum height. And a couple of things happen here. One of the key pieces that we're going to take advantage of is that at the maximum height, the velocity in the y direction is 0 meters per second. So when you're choosing your coordinates and you're choosing your time frame, you're going to say that, well, your coordinates, you call that the origin 0, 0, where you start from. But more importantly, the time frame, you get to choose that. So you might as well choose a time frame that includes this end point, the final equals 0 could be. Or you could call that the initial. Let's call it the final. So we know that the initial velocity in the y direction can be determined using trig function. Since we already have the 10, we can get the Vy in the I direction, or sorry, Vy from the 10. So let's do some vertical math. Vertically, that's all we really care about is things that are up and down to determine max height. So common mistake students tend to put is they'll say, oh yes, the initial velocity is 10 meters per second. No, it's not 10 meters per second in the y direction. It might be 10 meters per second overall, but that 10 is not going upwards. Some of that 10 is. That much of it is. So what is that much? Well, we know that the ratio opposite to hypotenuse is the sine function, so we're going to relate those two by the sine function for 30 degrees. So your initial velocity upwards is actually 5 meters per second, and we can use that. We also know that the final velocity in the y direction we talked about is going to be 0 meters per second. The acceleration, since we're on Earth, is negative g, or negative 9.8 meters per second squared. And the change in position, that's what we're worried about. The change in y position, we'll call that y max. Max. That's what we need. Well, if you look at the previous video, we solved this exact same problem, so we don't have to do the algebra twice. When we solved it, we got delta y max is equal to VIY squared over 2g. Well, we've got all that information, don't we? We've got VIY of 5 meters per second squared. I won't use units until the end, but it's always a good idea to use units. Divided by 2 times 9.8. And then we get a number that's about 1.25, I'm just guessing here, meters tall. And that should be it. So your delta y to your max height should yield 1.25. And that's how you get maximum height for a projectile launched at an angle.